Hey everybody, this is Larry. This is the first day of the September Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this problem. I'm going to be doing this all month as I have been the last year and a half, which is a long time now that I say it out loud. But yeah, just come and join us on Discord, just chat about problem solving and stuff like that. So today's problem is array nesting. So my style is also that I usually solve these live. My philosophy is that if you're just looking for someone to explain the solution, there are probably a lot of videos out there anyway. So I'm going to solve it live so I can at least think about or talk about my thought process and how I approach the problem, things to look out for from an experience perspective and so forth. Yeah, but it depends on the problem because sometimes the problems are like very straightforward and I don't have anything that interesting. But it's a journey. We'll see it together. Anyway, yeah. So today's problem is array nesting. Okay, so you should build a set such that S of k starts with a selection of nums of k. The first element in this set. Man, this is a lot of abstracting in the beginning. The next element should be nums and nums of k. Okay. Stop adding before a duplicate element. I don't know. Return the longest length of a set. So this is 5. This goes to 5. 5. What? So this is 5, and this goes to 6. Oh no, whoops. No, they want to start it up 0. So then this is 0, and then 5, then 6, then 2, and then 4. Why not 4? Oh no, I missed 2. 2 is 0. Okay. Okay. I think I understand the problem now. The short answer about this is that you can actually just try for every number. And you may think that trying for every number, you may think that for trying every number, it could be adverse n squared because for every number, if you have to look at every number, and the worst case, well, I mean, there are a lot of worst cases, but the easiest worst case to visualize is something like 1, 2, 3, 4, 5, 6, 7, n, or n plus 1 maybe, so that this number, when you look at this number, it goes to this number and this number and this number and then so forth, right? One after each other. And that's going to be your worst case if you try to do it for every number. But you can do this in a linear time in a straightforward way by just memorizing or remembering what the best answer is for that number. And then that's it. You could do this recursively. You could do this iteratively. How am I feeling right now? I'm gonna do this. Yeah, let's do this iteratively because I feel like I do a lot of things recursively these days, especially in Python, as you know. So yeah. Okay, so then now we can just do something like next. This contains the next element, or the element that this is pointing to. So answer equals I is the index. Is that right? No, we know the next number, so maybe that doesn't make sense because nums is a pointer. So another way to think about these nums array is that it is a pointer to the index, right? So this doesn't make sense. But what I want to say is this is actually, let's just say length of I, L. Maybe that's more useful. Is the length of the sequence starting at index I. Okay. Of course, let's just start this off with -1, just as a kickoff, times n, where n is the length of the nums. And then now we can just do a straightforward for I in range of n. We can solve I maybe, and then do we return the longest index or the longest length? Okay, so longest length, then here at the end you can just return the max of the length. And then we have to do the solve, which we'll do iteratively, as I said, even though I set this up maybe a little bit the way it's a smaller abstraction. So here we go current is equal to I because that's where we're starting, and then while length of current is less than 0. I think even 0 should have been okay, but yeah, that's fine. Oh, I guess iteratively is a little bit. I mean, you can do this iteratively, but then you need to use a stack so that you update everything else. Okay, maybe I lied then. Maybe I'm gonna do it recursively. I mean, you could do an explicit stack, but with generally, depending on how I do it, then yeah. Okay, then we'll do it explicitly. So yeah, so then here, then we can just do L sub I is equal, and this is, if we kind of do, if you think about how we do this, then this is actually a very easy thing to call memorization or dynamic programming, kind of, if you want to call it that. But yeah, if L sub I is greater than, if this is greater than or equal to 0, we return L sub I. Otherwise, we return south of number sub I, right? We have to make sure that number sub I is inside the index. Oh, and it is. So we don't have to check that. And all the numbers are unique, though I don't think that matters, to be honest. At least the way that we solved it. Because I think, yeah. Okay. So the only thing that I have a concern here is that for the n is equals to 10 to the 5th, we may run over stack limited exceeded, depending on your language. I know that they set it up, so we'll see, because this is a very lightweighted recursion. Oh, did I mess this up? Oh, I didn't cache this, that's why. Well, that's one of the reasons why. This seems a little bit awkward. This feels a little wrong now that I look at it again. But oh, the number can be itself. Can there be a cycle? I guess there can be a... No, I mean... Oh, I guess the way that they phrase it, there can be a cycle, and that's a little bit awkward. Okay. Well, if there is a cycle, it doesn't matter which one of the... No, that's not true. It actually might... This gets a little bit interesting then. If there's a cycle, what does that mean? Because there are a couple of scenarios in which the cycle might matter. Because it depends. Because every number in that inside a cycle has the same length, right? It's the longest length. So that's okay. So you have that. But then, so maybe I didn't think this through a little bit. For some reason I thought this would be a DAG, but I made a mistake here. Oh, okay. Actually, no. Then the numbers being unique matter, because I was going to say, so that in that cycle case, there are two cases, right? One is that the cycle is a cycle, and then two is that you have a lambda type, not lambda, the a row type thing, similar to like a loop in a linked list where you have like a thing where you have an entry point, right? So, and I could draw that if I want, if that's important, but because they're unique, there is no such thing as the loopy thing where you're entering, because in that case that means that two numbers map to the same thing. Let me actually, I was going to debate drawing it, but let me actually draw it. Hang on. But yeah, but basically what I'm saying is that there are two possibilities in a cycle, and that's what I'm thinking about. There's one which is here, which we have to resolve. Whoops, let me use another color so that's a little bit less confusing. So you have this one, which is what we were talking about, and then you have this case. But this case cannot happen because because that means that at this point there are two things pointing at the same number, and we know that every number is unique, so that cannot happen. So okay, so then that means that we have to think about the cycle case. Okay. How do we think about a cycle case? We can update every number in the cycle. Okay, so I think that's just it. It's just that we have two possible cases. One is what I did, where there are no cycles, and then the other is the one with a cycle. Is that true? Just want to make sure that. Oh yeah, I mean, even this one is a cycle. It's just that's why this is infinitely looping. So then you just have to get the length of the cycle, and then that's it. Okay. So yeah, let's see. How do I want to do this? Like, what I want to do is something like if cycles of I, then you do this thing, and then if there are no cycles, we do this thing. Like, that could work. And we have to think about how to do it in a smart way. But we can also just put this inside part of the solve as well. It just means that we have to set another flag. Also, this is just wrong anyway. What I mean, I need this +1, but what is the clean way to do it? So I know, I mean, I could write some hacky thing. I think right now I have the idea, but I'm trying to think about what's the cleanest way to write it. At least in a way that like it's clean and doesn't get into n squared by accident, because you can very easily write this in a way that you make a mistake and then it becomes n squared. So that's why I'm trying to be a little thinking about carefully. And the more, sometimes a lot of the programming is done in your head. So, okay, maybe I just pass in a set. And that means that this is a cycle. So if there's a cycle, what happens? That means that everything in scene has the same length. Okay, that makes sense actually. Yeah, okay. So then we return. This is very awkward because of all this stuff. I'm trying to think about the interaction between all this stuff as well, because we have seen yeah, maybe we just return two things, where instead of just returning before, this just returns the size of the thing, but maybe we can also return the boolean of the thing, of whether there's a cycle. Length is cycle is the output, and then here then we can return we can say yeah, we can return false, because as we said, there's no like loopy thingy that there are no two entry points to the loop, right? So so this is false, only this matters, so that you don't have a weird situation where you have to handle it, I believe. Anyway, otherwise we're seeing, then we just return something like this, say. And now we return some number and is cycle. And in that case, in this case, it is say, let's just say, I'm just trying to think about a variable name. I just call it x for now. So x is the length. We return that, and then if is cycle, then we just return x is, and this would be, we know that x is 0 anyway. Then we just this. Otherwise, we set L sub I is equal to x, and then we return x force, which is also a cycle, I suppose. Yeah. I think that's all I need to do. I mean, this gets, I mean, this is now wrong, but obviously. It's +1. Of course, we have to update all these numbers in the cycle, so we have to do that. I forgot, because I'm doing them in a weird order. So yeah, for x in scene, L sub x is equal to length of this cycle. Oops. So yeah, okay, let's see again. Okay, this looks good. We want a big test case. So one thing that I've been doing recently, at least for Leetcode specific, because you would just write like if you are able to write test cases, you would just write a test case, right? But here, it is a little bit annoying to kind of write code to write these test cases. So I've been doing this. I don't know if it's a good pattern. We'll see. But so I'm just gonna use this to test the big case. Something like that, and then we could run it and then see if it runs, because I'm just thinking about performance. Okay. I don't know if the input is right though, so this could be a different thing, because I think this should be, I think this -1 actually. So that's the thing you don't get, is that you don't get input validation, so you have to be a little bit careful. But oh, the last number is wrong. Oh wait, no, yeah, whoops. I messed up in the connecting. We want the last number to point at the first index. Yeah, that I was just making everything shift 1 over to see. And this is the expected answer, so we're good here, I think. It's just that I made a mistake on the code generation. Okay, so let's run it again just to make sure that I don't have anything lingering. All right, let's go. Let's give it a submit. Hopefully we're good. But there may be some weird edge cases. Okay, cool. So what is the complexity here? It is very weird to look at, and this is more awkward than usual. But the complexity is just O of n, right? Because for each cell, we look at it. We look at it once, because either if it's in a cycle, then it's set in a cycle, and we never look at it again. Yeah, if it's set in a cycle, then we only do it again. If it's not in a cycle, we do this recursive thing and we do it, right? And another way of looking at it is that we only ever set this update once. So that means that for each number, we only process it once, right? Because every index can only be in an input once and in an output once, roughly speaking, because of this thing. Right, so we never do this loop more than once for each number, and that's why this is linear time. And of course, it's linear space because of this thing, and also scene to a degree. So yeah, linear time, linear space, and that's all I have for this one. It's a little bit longer than I would like, because I don't think it's that hard, but I think it's worth being through. Anyway, have a good start to September. Hope y'all are doing all right. Stay good, stay healthy, to good mental health. I'll see you later. Remember, we'll be doing this all month and for as long as I can. So I'll see you in a bit. Bye-bye.